Good morning, everyone. A warm welcome to all the users who are connected with us in this AIOUG North India Chapters webinar series. That we conduct this webinar every sixth week, and just like that, this is the last of 17. In this webinar, we have bring you an introduction to Exadata and Smart Scan feature of Exadata. Before we begin our webinar, I would like to thank everyone for the overwhelming response we received this year in Sangam 2017. 9 years, we received almost come all across from Delhi, NCR, Gurgaon, and they come to Hyderabad. We are trying our best to bring Sangam probably in not next year, but to Delhi if we keep getting such response from you guys. So please do come on our regular events and on OTN Yatra, on tech days, some sufficient numbers to present it to board. Most of your time, as it's Saturday, here is there. I'll hand it over to Aman. Aman, can you start now?
Hi, Deepak. Can you hear my voice?
Yeah.
Hi, Deepak. Can you hear me?
Yeah, Aman, I can hear your voice.
Okay. Are we good to go?
Yeah.
Okay. So thanks a lot, Deepak. And thanks everyone who has joined us or who will be joining us for this webinar. As Deepak mentioned, we actually do this webinar on every sixth week of the day, of the time. And this is going to be the last webinar for the year 2017. Of course, we do actually upload these webinars on our YouTube channel. So please do go ahead and subscribe and go ahead and check the previous ones. We also have started uploading something called a quick tip series, which is basically going to be a short, less than 5 minutes, video tutorials about certain things. So again, check for that as well. So this particular webinar is basically going to be about the Exadata and the Smart Scan. So this is actually the introduction to the Exadata and introduction to the Smart Scan. So my name is Aman, and I welcome you all to this webinar. This is about me. I'm an Oracle ace. I have been working with the Oracle database for some time. I am a contributor to the Oracle OTN, or now the Oracle ODC, Oracle Developer Community Forums. I am co-author of 2 books. You can see the names here. And I have been a member of All India Oracle User Group, AIOUG, and I'm a member of the North India chapter team. I was a founder member. I'm the lead of that. I'm a part of AIOUG board of directors. So that's about me. So before we start, let's say thanks to the Oracle ACE program. The Oracle ACE program is actually the program from Oracle Developer Community, previously known as OTN, Oracle Technology Network. And Oracle ACE program is basically the program to recognize the people who are proficient in their technology, and they're also willing to help their knowledge with the peers across the globe. There are 3 levels for this program: the Associate, the Oracle ACE, and the ACE Director. There are different set of obligations which you need to actually do in order to qualify for these programs. You can actually be an author, you can be a blogger, you can be a Oracle Forums contributor, you can be a presenter, and based upon your contributions, Oracle Developer Community, ODC, is going to recognize your skill sets and is going to recognize your contributions and will award you either the Oracle ACE Associate, ACE, and ACE Director. The ACE Associate is the first level in this ACE program. You will be upgraded to the Oracle ACE if you keep on doing the same tasks, and you will be helping the people around the globe. The ACE Directors are actually more having more formal link with the Oracle product managers, and ACE Directors are the community leaders in their own technology. giving the input to the Oracle, and even um, spreading out the word about the Oracle technologies in the Oracle community. So in case you think that you are actually qualified enough to be nominated for this program, you can actually do a self-nomination of yours, and even actually ask any Oracle ACE or ACE director or associate to do the nomination for you. You can connect with the Oracle ACE program on the social media links, and of course, you can check for the details on the Oracle Developer Community website. Now, this is what we are actually going to talk about. So we'll be talking about the Exadata. We'll have a brief introduction to the Exadata hardware and network. We'll talk about how the Exadata is actually going to work in terms of the key features, and we're actually also going to talk about the Smart Scan. And we will also have a brief look at the Exadata Cloud Service, which is actually going to be a small introduction of that. Now, whenever we have a database server setup, which is actually going to be a setup that is going to be running a database instance, we'll be having bunch of nodes. The bunch of nodes are actually going to talk to a storage environment. And of course, within the environment, there is going to be the network. Now, this is a kind of traditional setup which you're going to be finding all the time, and this actually could be something which could be for a single instance, or this could be for a rack environment, but this is pretty much going to be the same kind of environment which you're going to find all the time. Now, this is basically going to be for the rack environment, so you can actually see that when you come to the rack part, the setup becomes even more complex, the setup becomes even more messed up, if we can say that. Now, this is something which is actually going to be somewhat a problem, because there can be many things which actually can go wrong when there are going to be performance issues, or when there are going to be, performance findings about performance issues. So the database itself, the DB servers itself, actually can have a problem. The network actually can be having a problem. The storage can be a problem. The database itself might have got some issues. You might have got configured wrong parameters in the database. You might have not set up the database properly. For example, you might have not been using the automatic memory management, or the automatic memory management available from the Oracle version 10G. You might have done some mistakes in creating up your application. You might have not used the proper or the optimal ways to design your application. So any of these things possibly can go wrong. Now, of course, we can't really tune some of the factors, like we can't really tune application code, especially when the code is not actually designed by you. It's not an in-house code. But there are certain things which you actually can, optimize, and that's where basically the things are actually going to be, taken care with the Exadata box. Of course, despite being the person who is going to take the responsibility of the database and trying to take care of everything, still the DBAs actually can find themselves in a tight spot whenever there is going to be performance issues, especially the issues which they really cannot actually handle by themselves. So that's where the Exadata actually comes and shines. So Exadata is basically an engineered box available, from the Oracle Corp. Oracle Exadata basically is a machine designed to work, with both kind of environments of OLTP as well as a data warehousing environment. Definitely, this is actually going to be a machine which is built by Oracle. So the bandwidth, the amount of configurations available in the Exadata box are top notch. And this machine is actually going to be a machine which is designed to give you the best of the performance and the best of the high availability. Of course, this is going to be taking care of many of the things which actually can be a bottleneck in a traditional database server setup, which we are going to see actually, in later part in the presentation. And this is obviously going to be, because it is engineered box, it is actually going to be more easier to configure. It is obviously going to be more easier to implement, and being actually maintained by Oracle itself. Definitely, this is actually going to be, taken care by the Oracle for the entire part. Now, definitely, this is going to be, the machine which actually can be used by you even for the cloud environments. And even the Exadata itself is available to you as a cloud service. A brief look of that we'll see at the end of the presentation. So Exadata box is basically going to be an engineered box. Comes along with majorly two kinds of servers. like any other database environment, the Exadata box is basically going to be having the environment of two. It is going to be having something called the DB nodes. The DB nodes are basically going to be the nodes which are actually going to run your database environment. The database environment means it's going to be database instances, your ASM instances, your database software, and so forth. In terms of the storage is actually going to be available to you by something called the storage nodes or something called the cell nodes. The cell nodes are basically going to be the nodes which are actually going to be running your storage disks as well as your flash cards. Now, depending upon your requirement, you do have different configurations of this box actually available to you. You do have, first of all, two families for this Exadata box, something called X-2 and something called X-8, which is actually going to be a two-socket servers and eight-socket servers. The X-2 family is actually available to you further in terms of different configurations, which you can actually opt for depending upon what kind of box or how bigger kind of box you basically actually need. The X-8 is actually going to be available to you in a single configuration, which is going to be known as the full rack. Now, to actually connect these boxes, the DB nodes and the cell nodes with each other, you're basically going to be having a network which is actually going to be running with the help of something called InfiniBand. InfiniBand, which is actually used within the Oracle Exadata box environments, is basically going to be using an InfiniBand class known as QDR, standing for Quad Data Rate class. The Quad Data Rate class is able to give you the 40 gigabits InfiniBand internal connectivity speed with all the ports active, and this roughly comes around about 5 gigabytes per second of the bandwidth, which you can actually get from this particular InfiniBand. For the connectivity of these DB nodes to your corporate environment, you do have the options to connect with either a 10 gigabit or a 1 gigabit Ethernet connectivity, or even to optical fiber connectivity as well. Don't really bother about these particular hardware specs over here. The specs are actually going to change. The latest version available currently is with the version X7. The hardware is actually becoming cheaper, and that's why it's actually becoming more powerful in the later systems. There are going to be changes coming in the hardware stack all the time, so don't really get stuck upon this particular notifications over here that these numbers are going to be something which you need to remember or care about. For the next every release of Exadata box, there is going to be a different hardware change which you actually will be finding out all the time. Now, in terms of the configurations, the Exadata box starts per se, or at least has started from the X3 onwards, with something called a 1/8 rack. The 1/8 rack is actually going to be the smallest configuration that you can actually get. The 1/8 rack starts with two set of DB nodes and three set of cell nodes. But in terms of this configuration, half of your configuration, for example, your CPU, for example, your RAM, is actually going to be disabled. The box comes definitely with two DB nodes and three cell nodes, but you cannot use the entire configuration of the hardware right out of the box. You basically will be having about half of that available, and the other half is actually going to be disabled in terms of the BIOS. If you do feel that you actually want to have the complete hardware for your disposal, you can basically do the upgrade from the 8th rack to the quarter rack, which is exactly the same configuration. It is still going to be the configuration of two node DB nodes and three node cell nodes. The configuration difference between an 8th rack and a quarter rack is going to be that this particular configuration is going to be available to you completely. So there is not going to be any kind of stoppage in terms of using the hardware for you in terms of this part. The quarter rack can be further upgraded from the quarter rack to something called half rack, where the number of DB nodes will now be 4 and the number of cell nodes are actually going to be now 7. And in case you want to actually go for the complete stack, then it is going to be the last configuration available, which is going to be the full rack. The full rack is basically going to be a configuration where the number of DB nodes becomes 8 and the number of cell nodes becomes 14. Now, this was the configuration which was available to you, till X3, X4, and so forth, but people actually had the demand that they wanted to actually have flexibility in choosing this particular hardware. For example, you may be a company who possibly needs more storage. You don't really need too many of the DB nodes. So that actually brought up the option to have something called the elastic configuration. So the elastic configuration basically is the configuration where you actually do start from the quarter rack itself. That means you still do actually start with the 2 dB node and 3 cell nodes initially. But then you have the choice to fill up the entire rack. And when we say rack, this basically is the entire cabinet of the Exadata box that you actually get from the Oracle. So this particular box actually can be filled up by you depending upon your requirement, and you can actually decide what kind of configurations you basically want for your DB nodes as well as for your cell nodes. Up to 22 nodes, you can actually fill this box, and you can have any combination of the storage as well as the DB nodes in that part. And of course, you can also decide, in case you're looking forward to have a machine which should cater for your entire OLTP workload, you can even go ahead and use the flash drives actually for this particular Exadata box as well, which comes as a part of elastic configuration. So you don't really need to stick to the standard quarter, half, full, or 1/8 configuration per se. Now you can actually decide to go ahead and choose the configuration which actually suits your requirements optimally. So after this basic overview, now in terms of the Exadata management, we basically have the major magic actually going to happen in terms of the storage servers. The storage servers are basically going to be the fixed set of servers coming along with certain number of disks and certain number of flash cards, and they're actually going to be managed by these three particular accounts. You have an account called cell admin, you do have an account called cell monitor, and you do have an account called root. The cell admin is basically going to be the sort of like the DBA account on the storage servers, using which you can actually manage a utility called cell CLI. From the latest versions, we do have the similar kind of utility available from the DB nodes as well, known as DBM CLI. The cell admin actually will be available to you to use to configure the storage servers, to manage the storage servers, to troubleshoot, and so forth. The cell admin has all the rights on the storage server. Definitely, you can actually use it to customize and do the admin tasks. In case you just want to give the access to the storage servers to someone for your own purpose, you would be able to actually do that with the help of something called cell monitor user. As the name says, the cell monitor user is basically going to be a user which just have the list privileges. It does not really have privilege to modify anything on the cell servers. And of course, you're going to be having a root account as well, which would be having the access of the same as of cell admin user. Now, these three users actually come pre-created on these particular storage servers. In case you basically want to create your own set of users and you want to grant them privileges, depending upon your requirement, even that is actually possible. So you can actually go ahead and do that part, in case you're basically going to be requiring it from your from yourself. Now, in terms of the storage servers are actually going to be having a specific layout, which is actually going to be, we are going to discuss over here. So every storage server is basically going to be a server which comes actually with its own set of CPU, with its own set of RAM, and with its own set of operating system, which basically makes every storage server actually a working computer. We need that particular functionality to be there for the features of Exadata, which are actually going to make it, the super performing machine. So every storage server basically comes with 12 set of hard drives and 4 set of flash cards, the PCIe based flash cards. The latest versions, now we are basically having the same available to us in terms of the NVMe based flash cards, which is basically non-volatile memory express cards. The configuration of the disks is actually going to be the high capacity disks available to you now. And of course, as I said previously, you don't really need to look for the configuration of these disks or the size of these disks, because that keeps on getting bigger with every introduction of the latest iteration of the Exadata version. But the number of disks remains same in every particular configuration. So each cell server comes with 12 drives, physical drives, and 4 flash cards. Now, these drives are actually going to be exposed to you in terms of LUNs. Now, for each physical disk which is available to you in terms of one cell server, Oracle is going to create for you one LUN, which means every disk is exposed to you in terms of one LUN. So that means if there are going to be 12 disks available to you, there are going to be 12 LUNs actually available to you. Each LUN will be of the same size, which means there is no such thing that one disk or one LUN is actually going to be of dissimilar size compared to the other LUNs. This configuration is a little bit different for the first two disks in your Exadata cell server, because in the first two disks, the roughly about 29 GB of the space is actually going to be reserved for the operating system as well as for the cell software. And why two? Because the first two devices are actually the mirror LUNs of each other, which means you can actually understand this sort of like the system partition or the master partition, which we normally have, actually been observing now in the consumer class laptops or desktops, which comes pre-installed with the operating system. So you normally must have seen that if you purchase a disk of about 512 GB and you basically actually have the Windows installed over it, or Windows pre-installed over it, roughly about 7 to 11 GB of the space is actually not visible to you. And that space is basically the space which is actually going to be occupied, or you can say reserved, by the system, or you can say by the Windows operating system for itself. In a similar fashion, on the first two devices, the operating system, which is default for the cell servers to be Linux, and the cell software will occupy about 30 GB space. So to reiterate myself, every cell server comes with 12 disks, the 12 physical hard drives. The 12 physical hard drives are actually going to be converted into 12 LUNs. Out of the 12 LUNs, the first two LUNs are actually going to be having about 30 GB space not available for you, which is going to be reserved by the system for itself. That means for the operating system as well as for the cell software. This configuration is basically going to be available to you similarly across all these storage servers. Now, this is going to be the system LUNs. Now, the next layer of the abstraction after this particular system LUN configuration is basically going to be the cell disks. Now, the cell disks, I would like to explain it as something like the primary partitions. So you basically actually get the entire disk available to you in terms of system LUNs. And after the system LUNs, you're basically going to be exposed the LUNs as a usable space in the form of something called cell disks. Now, the cell disks, as I said, is going to appear, or it's going to work like the primary partition, which basically means you can go ahead and use it as like your C drive. Now, in case you're going to be using Windows, you basically get the disk exposed to you about the mount point character, which is C colon in terms of Windows. Now that basically means after this particular mount point or the mount character C drive is available, you can actually go ahead and format that disk and it becomes actually a block device, and you can actually start using that device. The same thing is going to be there for the cell disks. So once the system LUNs are actually going to be available, you can actually carve out from them the cell disks, and then the cell disks actually can be available to you for your own usability in the form of another set of abstraction layer, which is actually going to be called grid disks, and we'll see that just in a minute. Now, in terms of this particular configuration of the system LUNs and the cell disks, this entire thing is normally going to be not required to be created by the by the owner or by the customer of the Exadata box. This most likely will be done or will be configured by the advanced customer support engineers, which will actually come and configure the box for you. So you're going to be getting the 12 disks. You're going to be getting 12 system LUNs with first two LUNs minus of 30 GB space, and then the entire system LUNs are going to be exposed to you in terms of cell disks. Now, the cell disks actually are available to you in terms of two fashion. You can actually use the entire cell disk as a complete disk, which means there are 12 cell disks. You can actually go ahead and use the 12 cell disk completely. Again, if you pick up the example of the primary partition in Windows, you actually do have an option to use the entire disk as a C drive or as a C colon drive. Or you can actually go ahead and create from this primary partition something called the extended partitions. Now, the benefit of the extended partitions is not about performance, but the benefit is basically going to be about the usability and the manageability, and obviously the privacy which you actually get from creating this extended partition. So if you create a C drive and a D drive, the D drive can be used by you to store the data which you possibly deem as your personal data, like your Excel sheets, your PowerPoint slides, your movies, pictures, and so forth. So this is basically not going to give you a performance benefit, but of course, a manageability benefit you're actually going to get, because now from one disk, you have basically carved out two logical chunks of the devices, which would actually appear to you as two disks, two logical disks coming out from one single hard drive. Of course, doing this is actually going to reduce your bandwidth as well, but obviously going to give you a better control on the manageability of the content which you're actually going to create on the disk. In the same way, the cell disks actually are available to you in one complete chunk. So you can actually carve out from one cell disk a complete chunk which can be used by you, known as one grid disk. Or you can actually go ahead and further partition this particular cell disk into multiple chunks depending upon your requirement. So it basically means you can actually have 12 cell disks which cannot change. The 12 cell disks can be available to you in terms of 12 disks, or if you go ahead with the route of carving out the partitions out of this particular cell disk, you can basically go ahead and use the same in terms of multiple grid disks. This actually gives you an option to use another feature called interleaving. So basically, the idea is by default, the consumption of the devices is actually going to be from the outside to the inside. So in case you're going to be creating from one cell disk multiple grid disks, the outer side tracks are actually considered to be more faster compared to the inner side tracks. And the reason for that basically is in terms of the one rotation of the head over to the drives from the outside tracks, it is deemed to be actually giving you more access of the data compared to the inner side tracks. So if you do actually want to configure your disks in such a way that the inner side tracks most likely will be used by you to store the data, which most likely would not be something which you would be accessing very often. In that case, you can actually go ahead and use the inner side tracks for something like the RICO disk group, or the RICO DG, which is actually going to host your particular backups. Speaking of that, basically it means that you're going to be having ASM used as an essential thing in your Exadata box for the storage management. And since it's going to be an ASM environment, the entire configuration of the disks is actually going to be available to you in terms of disk groups. Just like normally we create ASM, we are going to be having over here as well the disk group called data, which you would be actually using in terms of creating your particular database or databases. And the FRA disk group, which is actually available to you in terms of non-Exadata environments, the same is actually going to be exposed to you in terms of the RICO DG. This name change is basically there because in terms of Exadata, there is obviously going to be a lot of flash keyword used at many places. To avoid the confusion, that we are talking about what kind of disk group, the Oracle actually calls your FRADG in terms of Exadata, something called recode DG. So we were speaking about the interleaving. So the point basically is, in case you basically want to configure multiple grid disks, the consumption of the devices is actually going to be from the outside to the inside. And in case you do not really want to use your disks in such a way, you basically want to use the entire disks in a complete even manner, you can actually go ahead and create your devices where Oracle will be using your devices partly from outside and partly from inside. So maybe possible, I don't really want to use or consume my devices in such a way that one chunk is actually going to be exposed by me as a chunk which I seldomly actually going to use. So that chunk basically is going to be also available to me as a normal drive. So this is basically an option that you can actually go ahead and make while configuring the Exadata box in the initial stages, that whether you really want to create multiple grid disks or not. And in case you want to do that, you actually will be getting it done either by yourself or the Oracle advanced customer engineer will be actually doing it for you. After the devices are actually created, the grid device actually going to be created, they will be serving as the candidate disks for your ASM. So ASM, as you already know, does not really care about that whether you're giving it a physical hard drive or you whether giving it a drive, which is actually a logical drive available by some partitioning and so forth. So the same case is over here. So when the grid disks are actually going to be created, whether it is one grid disk or whether it is multiple grid disks, each of them is actually going to be a candidate disk now for the ASM running over the Exadata box. ASM is going to be a mandatory option in terms of Exadata environments. And ASM is the only way to manage your storage in terms of Exadata boxes. So basically, ASM will support in terms of Exadata environments the redundancy as well as mirroring as well as the striping options. In case of normal normal boxes where you actually deploy ASM, you do have the option to disable or not to opt for ASM based mirroring. But in case of Exadata boxes, the striping, which is obviously going to be a mandatory feature or a very good feature of ASM, is going to be there. But the mirroring, which is in the form of redundancy, is also going to be there. So you can actually either opt for a normal redundancy or a high redundancy. The option of external is not actually going to be there. So once you've got your devices actually available to you, you can basically go ahead and start using them for your databases. So in order to sum it up, we are going to be having 12 disks in one cell server. And in case we talk about a quarter rack, we're going to be having 3 cell servers, which means we're basically going to be having 36 physical disks. And in case we're going to be carving out from 36 physical disks a system LUNs, we're going to be having 36 system LUNs with the same number of cell disks and with the same number of grid disks, which will end up in terms of 36 ASM disks. And each of these disks actually can be available to you for your disk groups. Now, in terms of the networks in Exadata boxes, we're basically going to be having the networks available in the boxes, from your DB nodes as well as your cell nodes. Now, uh, it's not really actually different from what you actually do in a normal box where you do have the option, especially in case of rack environments, where you do have the option of something called a public network and a private network, where the public network is a network through which you basically manage your database nodes actually available to your corporate network, and the private network is a network through which the nodes actually have a talk in between, or you can say do have an internode talk. Now, in terms of this Exadata boxes, we do have the similar kind of network, though the names are a bit different actually over here. So in terms of the Exadata boxes, we are basically going to be having the DB nodes and the cell nodes. And the DB nodes and cell nodes are basically going to be connected through a dual channel host HCA box as a host channel adapters. Now, in terms of Exadata boxes, we are basically going to be having the InfiniBand network in place for the so-called private network in terms of the DB nodes and the cell nodes. The Exadata InfiniBand switches are actually going to be used for this configuration. Each switch is a 36 port switch, and Oracle uses 7 links by default for the communication for the DB nodes and the cell nodes. Now, this configuration is available to you in terms of active passive or active active in the latest version of Exadata boxes. So you can actually see that I'm trying to expose the same thing by 2 different colors. You can actually see that one color is representing active and the second color is representing passive. The DB nodes are actually going to be having the options to be available in terms of a bonded network. The term bonding basically means we'll again use two network layers, or you can say two network ports actually to expose the DB nodes to your client network. So the DB nodes are basically going to be the nodes which are actually going to be used by you to connect to your corporate network. Now, this is again something which is available on demand basis, you can say now. The default number of leaf switches available to you from Oracle starting from the X3 onwards is basically going to be 2. So you basically have 2 leaf switches actually available to you. Which is actually required for the boxes to actually work. Now, in case you want to scale out your Exadata boxes and you want to connect these Exadata racks to another Exadata racks, you do need some time another InfiniBand switch called spine switch. Previously, the spine switch was available to you in half racks and full racks by default whenever you purchase the box. But now that option is no longer there. So even for the half racks and full racks, the spine switch, which actually can be used by them, is not shipped by default. For quarter racks, it's actually not even available. Because the spine switch does not really participate in the actual functionality or the actual networking of the DB nodes and cell nodes, the default supply of this is actually not there. You can actually ask for it in case you basically want to go ahead for that kind of environment where you basically want to connect multiple Exadata racks with each other. In that case, you can actually opt for this spine switch. Besides this, we are basically going to be having Ethernet switch actually available to us as well. Now, Ethernet switch in Exadata box is basically going to allow you to have another network which is going to be not available to you in the non-Exadata boxes called management network. The purpose of the management network is basically going to be that in case you want to manage your boxes, for example, you want to start up the boxes, you want to shut down the boxes, or you want to do any kind of administrative tasks on these boxes, you would actually be using the Ethernet switch to do that. And from this Ethernet switch, you would be able to actually access the boxes with the help of something called ILOM. So ILOM, or Intelligent Lights Out Monitor, is basically going to be available to you with the IPMI interface. And as you probably must be knowing, the IPMI and ILOM interfaces are basically available to you to do the power state management of your components. So as soon as the machines are actually exposed to the electricity or they're powered on, using ILOM, you can actually manage the boxes, and you can actually have the boxes and the power state management through that. So Ethernet switch is actually going to be available to you for this purpose. The Ethernet switch does not really have kind of dependency for your database nodes being available or not, because Ethernet switch is not used by the Exadata box to actually connect your DB nodes to your corporate network. So in case we basically look ahead, we can actually see that the Ethernet switch is available to you for the InfiniBand switches. It is actually available to you for the DB nodes. And in the DB nodes, we're basically going to be having a dual port connectivity available to you, which actually can connect to your database servers to your corporate network. You can actually opt for, like we discussed, 1 gigabit or 10 gigabit, depending upon whatever is available to you in terms of your corporate network. So Net 1 and Net 2 are going to be the options available to you for this one, and Net 3 and Net 4 is actually going to be there for, Net 4 and Net 5 is actually going to be there for this one for the 10 gigabit. And in case you have optical fiber, or in case you have this 10 gigabit option available to you in your corporate network, you actually go ahead and use that as well. So you can see that the management access and the ILOM access is actually going to be done with the help of the Ethernet switch. The client access is basically going to be the access which is going to be for the exposure of the DB nodes to your corporate network. And in case in your company you do have the 10 gigabit network available, you can even use that to connect to your DB nodes. Since it is not mandatory and not everyone has it, that's the reason this is actually shown over here in terms of the dashed lines. Now, this is going to be the networking part in terms of the Exadata boxes. The software part is more standard. Previously, on the DB nodes, you would be actually having the option to have the Linux or the Solaris software to be actually available as the operating system. Now it is not the case. On the DB nodes and on the cell nodes, you actually get the Linux only as the operating system available to you. Plus, on the DB nodes, you would be running your databases, that means your database instances, and your ASM instances as well, which means also the GI software will be actually available to you on the DB nodes. Definitely, you do have the option to opt for a rack database on Exadata box, but it is not really mandatory. It is entirely up to you. You want to make a single instance DB on Exadata box, it is definitely possible. Or in case you want to make a rack database on your Exadata box, it is definitely possible as well. But it is not mandatory that you must be on rack in case you're going to be on Exadata box. Besides this, we are basically going to be having the option, the library available on the Exadata boxes, which is going to be a libcell shared object available to you. This particular shared object library is actually going to make your DB node take the benefit of the IDP, or the Intelligent Database Protocol, also known as ZDP, or Zero Copy Data Protocol, actually in the Exadata boxes. This particular protocol, which is actually going to be available to you, is basically take the benefit of the InfiniBand network and also the Exadata cell software in your systems. Now, on the storage servers, we are going to run the cell software, and the cell software is basically going to be available to you in terms of two major processes, the management server and the restart servers. So you can actually think of them as the major two processes running in terms of Exadata environments. These two processes are also available to you now from the latest versions like X6 and X7 on the DB nodes as well, which means you can actually connect to your DB nodes, and from there you can actually manage your cell nodes as well directly. So now if you do notice, actually you will see the same processes available to you on your DB nodes as well. And that's what I mentioned to you in my previous talk, that besides the cell CLI, which is actually the command line tool available to you to manage your cell servers, you do have the option to actually connect from your DB nodes using a utility called DBM CLI. And because obviously you do have the MS and RS running on the DB nodes as well, that means you don't really need to connect explicitly to these storage servers and do the management of them. You can actually do the same from your DB nodes as well through the DBM CLI. The manageability server is sort of like the main process, which actually takes care of the entire set of features of the Exadata box, and the RS, or the restart server, is basically going to be used by the Exadata to restart the MS process in case there is going to be an abnormal shutdown or abnormal kill of the MS process. In order for the connectivity part to be there, you're basically going to be having the entire thing managed by something called IDP, or Intelligent Database Protocol. The Intelligent Database Protocol is basically, it's actually going to be the RDS version 3 protocol. The basic point actually of this, or that's why it is actually going to be called ZDP, or Zero Data Copy Protocol as well, because if you're going to be using the normal, networking, the normal networking is basically going to load your data in terms of multiple layers in your system. So you're basically going to be having your normal layer, then it's going to be the TCP layer, IP layer, then polling layer, and then your particular communication is going to reach to your network card. But in terms of the RDS, when you're going to be using the RDS layer, you will be actually going to the particular network card, or you'll be actually talking to your network card without really doing this additional copy of the data in terms of different layers in the system. So you don't really need to copy your data first to the TCP layer, then the IP layer, then the polling layer, and then it will actually reach to your network card. And because of this copying not done, that's why the name is actually going to be called Zero Data Copy, or ZDP protocol. And using this IDB or Exadata InfiniBand interface as well, the commands which are going to fire on the DB nodes are actually going to take the benefit of the features like hybrid columnar compression or storage indexes or smart scan and so forth, which obviously will give you the performance benefit as well in your system. Now, the configuration of the Exadata box is done in terms of four major methods, or you can say phases. The first phase is basically going to be a pre-installation phase, which is basically going to be like taking an input from the customer or from the person who is going to be, or company who is going to be interested to purchase the Exadata box. The pre-installation phase requires the customer to be actually telling to the Oracle that what kind of options they're looking forward in terms of the Exadata box, what kind of configurations they're willing to have, and these entire things actually can be a back and forth communication or dialogue between the Oracle support and the customer DBAs. Once everything is decided, this entire thing is going to be used by the field engineers or the advanced customer support engineers to configure the box, which is going to be available to you on the site. Once this is done, the third phase, which is most likely going to be something which you can actually opt for, may not opt for, is to configure something additional. For example, configuring the cloud control to manage your box, or configuring the standbys and so forth, configuring the zero data loss recovery appliance, for your Exadata boxes for the backups and so forth. Of course, they are all going to be good and useful, but they're not really mandatory. So it's not really mandatory to have the cloud control for your box. It's not really mandatory to have the ZDLRA to be configured with the Exadata box and so forth. But if you do that, it's actually going to be good, and that's actually going to be part of the additional configuration. The last phase is going to be the phase which is the maintenance phase, or you can say the post-installation phase, where you actually can decide, how do you want to manage your box. For example, how do you want to do the cell patching? How do you really want to do the post installation maintenance of your system, doing the checks on your box? How do you want to check that your system is working fine and so forth? Now, out of all these phases, the installation and configuration phase is sort of like mandatory to be done by the customer support engineers, advanced customer support engineers of Oracle. You can actually opt to do that by yourself, but it's better actually that the ACS actually will come and do that for you. The additional configuration and the post installation is actually going to be your choice. You can actually do that by yourself, or if you opt for, even Oracle actually can do it for you. You can actually opt for a platinum configuration where Oracle actually can take care of this entire task, for you. The pre-installation phase was done by by Oracle, if you remember, in terms of previous Exadata versions, version 1, 2, and so forth, by using the Excel sheets. But now the same task is actually done by a tool called Deployment Assistant. The OEDA, or the Deployment Assistant, is basically going to be a tool which is basically a Java tool. And as you can see, there are a lot of dialog boxes actually available over here. And this particular tool is actually going to be a standalone tool. So you don't really need Exadata to be running actually in your environment. This is available to you for download from the Metalink doc 888828.1, which is actually the doc from where all the options or the things available regarding Exadata is actually going to be available for you to download. And this box is basically going to this tool is basically going to be the tool which the customer has to fill. And once the customer is going to fill this particular box, it is actually going to end up in creating an XML configuration file. And that XML configuration file is something which is actually going to be used as a source for configuring the box whenever it is actually going to be shipped to your data center, which is actually going to tell you that all the boxes are created equally for the Exadata environments. That means there's no difference in the box essentially from one company to another when the box is first shipped to you. But when the box is actually going to be starting to get configured based upon the inputs given by you in terms of this deployment assistant, the configuration actually will vary from a company to company, or even within a company, from project to project, or maybe from department to department. So this tool is actually going to be having a lot of options. Of course, I will not be going ahead with all these configurations over here, but this is basically what you would be actually using to tell to the Oracle that what kind of choices you basically want to make for your own Exadata box. Now, the entire configuration of the box is basically done by sort of like these steps. So you're actually going to be getting the installation requirements, talk to the Oracle support. You're going to be using the OEDA to check for the configuration files and create the configuration files. Now, Oracle actually will, the engineers will actually do network check using a script called check IP. The check IP is basically going to check the networks or the network IPs which you already would have shared with the engineers, before the installation is actually going to get started. This is going to do the readiness check for the networks, that whether all the IPs are actually going to be available. So there is going to be a script called checkip.sh, which is actually going to run by the engineers to check this thing that all the IPs, the DNS, and everything is actually working fine. A first boot is going to be done to check this thing that all the ports and everything is okay. The hardware is not really having any problem. The hardware installation is really not much because actually hardware is already going to come pre-shipped from the factory. The next part is to download the OEDA and something called one command, which is actually going to be a command used by the engineers to configure the box. So this entire configuration is basically going to be staged over the entire set of DB nodes. And from there onwards, the configuration of the machine is actually going to start with the help of something called the one command execution. The one command roughly executes about 19 to 20 steps in one single execution. Of course, the steps are done in an iteration, step by step, and you do have the choice actually to customize the one command or the Java one command as it is called now to stop the command execution at a certain step if you basically want it. For example, we discussed about cell disks and grid disks. For some reason, for example, if you want to create this grid disk as per your own requirement or customization, you can actually stop the command at the cell disk after the cell disk creation, and then you can actually take control of the configuration part for you. So that's basically going to be something which is done by the engineers actually. Not really suggested that you'll be actually doing this on your own. And one command and everything about Exadata box is downloadable by the Metalink Talk 888828.1. Of course, you can actually check, the same doc. It is a public doc, that what exactly it actually have. And you can actually go ahead and read about it from there as well. Which brings us to the Exadata box. So now you do have a box which is configured, which is ready for your disposal. So what actually makes Exadata box so unique? There are certain features in the box which are actually going to be there, and it is actually a small list of the features which we do have over here. So you do have lots of things like the compression, the flash cache, the IO resource manager, storage indexes, InfiniBand, and so forth. But for this presentation, we're just going to be talking about the smart scan. So we'll not really be talking about anything else. Of course, this is the most commonly or most popularly known feature of Exadata box, and that's basically the agenda for this talk as well. Now, smart scan, before you actually understand this thing, is basically going to be the term that is actually a little bit coming up from another term called offloading. The offloading is the actual term which is basically going to be there. So the purpose of the smart scan basically is that Oracle should actually not do any unnecessary work when you're going to actually need the data from the system to be actually available. For example, I want to read, for example, out of one block of 8 KB. Let's suppose, for the sake of example, that one block of 8 KB contains 4 rows, and each row is actually going to be available in terms of 2 KB size. So that means we are basically having 4 rows, and each row is actually going to be of 2 KB each. Now, in case I want to read just the 2 KB of the data, that means just one row, by default, the data has to travel to the buffer cache, and data has to be filtered from there, which is actually going to be giving me additional 6 KB of the data, which I don't possibly need. And that is basically going to be an overhead for my performance. Of course, I'll be filtering out the data, and of course, I will be actually getting the data read, but that is not really something which is actually what I wanted. The offloading term basically means that this additional data, which actually would travel to the buffer cache, and then it is actually going to be filtered out and given back to me, is not going to travel to the DB nodes at all, or to the buffer cache at all. This additional data will be filtered out onto the disk itself, and that basically is the term offloading. Now, the offloading term is basically means that the work is offloaded to the storage servers. Of course, this work of loading is not really going to be happening just for the query. It can be happening for different set of things. For example, it could be happening for your joins. So in Oracle from 10G onwards, there is a feature called Bloom filter. The Bloom filter is basically a term or feature which, if it is done on Exadata box, can be offloaded to the storage servers. Now, in case you're talking about the SQL statement, and you're basically talking about that SQL statements are actually going to be getting not any unnecessary data being traveled to the buffer cache, or not to the buffer cache, but to the DB nodes, then this is going to be known as, or you can say better known as, the smart scan. So basically, when you actually mean that offloading is happening for the SQL statements, it is actually going to be the smart scan. The smart scan basically is going to be a feature which is actually given to you from the Exadata storage server, from the Exadata storage server software. It is not really an optimizer feature, which basically means you really can't enable this sort of thing by having some hint or something in the optimizer. It is basically the benefit that you actually get from the storage servers, and it is limited actually for the table scans and index scans, and to for the room filters for the joins as well. But the smart scan, besides being a very good feature, does not really work all the time. It depends actually that what you're doing. So to take an example, if I do a select star from table name, that's basically asking for the entire data to be actually scanned from this table. Is it really going to be giving any benefit? Is it really going to be of any benefit to you in case Oracle be using any smart scan feature over here when you're actually looking for the entire amount of data for this particular table? The answer is no. That means you might see the smart scan being used for such full table scan query, but it wouldn't really be doing any benefit to you as such. So for the smart scan to work, you do need two of the things basically to be there. You do need a particular set of column or columns to be actually used in your select list or select command, or you do need a particular or a proper where condition to be used, and you could be using both of them in your query as well. But you do need either one of them to be present for the smart scan actually to work, and only then you can actually see, or you can actually get the entire benefit of the smart scan per se. The other thing about this particular thing smart scan is going to be that smart scan is basically going to use something called direct path read. Now, to take an example for this, coming from the same previous example that we just mentioned, if we do think that we have got an 8 KB block, which is actually the standard block size in database, and that contains 4 rows having each row of 2 KB each, and we are willing to read just one row out of the 4, which means we don't need the 3 KB of the data, how this data actually can be loaded into the buffer cache? In case you're wondering about the question, the idea basically is, if you're going to be having an 8 KB block that has to be loaded into the buffer cache, because the unit of IO in the buffer cache is actually 8 KB. So 8 KB has to be loaded into the buffer cache, only then the filter actually can be happening for the data. But if we will load the data into the buffer cache and then do the filter, then what is the smartness about it? So the point is, the data which we actually want to read is much smaller from the standard block size which is available to us in terms of the buffer cache. And that means we actually have to bypass the buffer cache in order to make the data available directly to our PGA. And that is basically going to be, if you actually remember, known as direct path read. The problematic part with the direct path read is the direct path read is basically going to be available to you automatically or by default for the parallel queries. Whenever you do a parallel query, the direct path read is actually going to be already enabled for you. That means the data is actually going to be read into your PGA right away. But if you're going to be using a serial table scan, which means you're going to be using a scan which is not really using parallelism for your particular table and for your query, in that case, the direct path read is not really going to be happening, because now the data actually be traveling to the buffer cache, and it actually will be loaded into the buffer cache, and then it is actually going to be filtered and given to you in your system. Obviously, this is really not going to be so good. And for this reason, to enable the smart scan basically to work in order to for serial table scans as well, a parameter called direct read is actually going to be available to you by default as true, which means if you're going to be having smart scan working for you, even for the serial table scans, the data which is actually going to be now fetched from the disk, which is actually going to be much smaller compared to the standard block size, is not going to go into the buffer cache, and it is going to be exposed directly to your PGA. So that means for the smart scan to work, the data must be a direct path read, and it should be not mandatory, but it should be a consistent read. Now, why it should be a consistent read? Because if you actually modify the data, the consistent read is not really possible, because now you do have a dirty data actually available, which is not yet committed. And of course, to have a consistent version of this data being available, you do need the undo blocks or the undo data to be actually applied over to your free blocks, and you actually have to make a CR version of your data. This entire thing cannot bypass your buffer cache, because the undo blocks are actually created in the buffer cache itself, and the CR blocks are also created in the buffer cache itself, which means if you do actually do a lot of transactions on your data, and that means you're actually going to be creating a lot of dirty buffers, and you actually want to use the smart scan for these dirty buffers, you would actually not be able to bypass the buffer cache. So obviously, when the data is going to be already a part of the buffer cache, the actual benefit of the smart scan would not really be diminishing, but it's going to be reduced. So that means when you're going to be taking the best benefit of the smart scan, you would need to have the direct path read, and as much as possible, you would need actually to have the data available in terms of a consistent manner. Now, in case the database is basically going to be requiring to use the smart scan for its queries, there is going to be a parameter called cell offload processing, which is by default set to true. It has to be set to true. And the disk group must have got the parameter cell.smartscan capable set as true. In order to have the smart scan feature being used or not for your query, you would be able to use the parameter called self offload plan display, using which you would be able to see a storage clause for your table scans and for your index scan. So this is basically a set of parameters you would actually be able to take the benefit from. Most likely you would not really be able to do anything about them, because these parameters are already set for the respective values. The serial direct read is already set from 11.1 as an internal parameter in your system, which basically means it is going to be a parameter taking care of the things that even for a single table scan, the direct path read is now going to be actually possible. Now, there are going to be options, or there are going to be conditions where the smart scan simply would not work. And this is a list of, partial list of such things. For example, if you're using an IoT, or if you're using LOPs and longs, some of them are actually going to be taken care in the next versions or the coming versions of the Exadata cell software. But if you have this list and you do check the Exadata documentation for the complete list, the smart scan feature simply would not be available. So how do you actually know that a smart scan is actually going to work for your particular query? Now, this is an example for that. We are taking this very quick example of a count star from employees with department equal to sales. And you do notice that in terms of the execution plan, there is a storage keyword actually shown to you. Now, you do notice the storage keyword is shown to you in the execution plan, and also it is actually shown to you in your predicate section for the execution plan. This does represent that for this query, Oracle actually have used the smart scan. Now, this is basically going to be a good indication that a smart scan is used for this query, but This could be misleading as well. Like, you might actually see the storage keyword being used, but you might not actually be able to confirm that a smart scan is really going to be beneficial for your query or not. And for this purpose, you would actually be able to use certain statistics, which are actually going to give you a little bit more insight about the same thing in your particular query. So you would be able to actually notice from this example that we are reading about 131 megabytes of the data. But if you notice actually the number of bytes returned by smart scan is actually far tiny, and that's basically one of the ways to actually check this thing, that whether we actually really get any benefit from the smart scan or not. So you can see that 131 is the total number of bytes that we're actually reading, but when we are sending the bytes actually in the network in the IO interconnect, it is actually a very tiny portion of this entire 131 megabytes. And that's basically going to be an example, or you can say a way to check that whether the smart scan is really actually being beneficial for us or not. The smart scan feature is basically going to work on the buffer cache. So if you really want to actually get to know the functions or the things working inside, you can basically go ahead and do an S trace or D trace for the process actually to check what kind of APIs are actually being used in the smart scan in the background. But of course, that will not be of much benefit because many of these APIs are not exposed, to us, to the public people. So not really actually going to be of much use. But of course, you should be actually able to see this thing, from the execution plans and from the other things. So you can actually see this is another example that we're taking. So here the query is actually same. So you can see the time actually has raised from the 2 seconds time to 6 seconds times. And here the amount of data which is actually traveling from 131 megabytes is now much higher. So we are actually sending about 89 megabytes now in the system, right? So the example basically is we possibly might be actually doing something additional, like we most possibly might be modifying the table in another session, and that is actually going to create more data travel for the Exadata for this particular query. Now, whenever you're going to be having the smart scan, do check, like I mentioned, the transactions. Of course, if the transactions are actually happening for your buffers, that will result into the dirty buffers. And for the reading of the dirty buffers, we do need the CR copies to be available for the other sessions. Since the CR copies are actually going to be available to you only in the buffer cache, that means the benefit of the smart scan is possibly going to be diminished over there. Whenever you use dynamic sampling, Oracle does a sampled I/O in the background before the query actually starts. Of course, for the actual query, the smart scan will be used, but for the dynamic sampling I/O, the smart scan is not actually going to be used, which is actually going to be added as an overhead for your query's execution part. So you do actually want to check this thing out, that in case you're using a lot of dynamic sampling, and for some reason, if you're using dynamic sampling in your system, all the time, this may actually be not, taking the benefit. This actually will not be actually taking the benefit of your smart scan functionality available to you from the Exadata environments. If you do have lots of migrated rows or chain rows, that is obviously going to be adding more overhead in terms of reading your data over the disk. And that is obviously going to be adding the time into your system. Since the entire work of SmartScan is done on the storage servers, and that means the storage servers actually would be used to do this entire functionality. If the storage servers CPUs are actually going to be more busy, they possibly would not be able to handle this additional task of doing the smart scan for you. In that case, they might actually send the data as it is to your DB nodes, and that basically means you would possibly not be able to get the benefit of the smart scan properly. And the last, obviously, is if the data is already cached, then there is no point actually doing a smart scan, for that particular data, because now obviously data cannot be really offloaded. It's already a part of the buffer cache. So that is basically going to be another thing which you possibly may want to actually look into, that in case you do have, the entire data which you're actually looking forward already in the buffer cache of your system, possibly the benefit of smart scan is really not actually going to be there too much for you. You can actually check this entire thing in terms of your system by using certain weight events or certain statistics. All the weight events and statistics for these Exadata is going to start from the name called cell. So you basically can check from there that are you spending actual time doing the work with the smart scan, or if you're not actually doing that, then where the time is actually being spent. So this is basically going to be about Smart Scan. Now, the last bit is basically the introduction to the Exadata Cloud Service. So Exadata Cloud Service is basically going to be the service available to you where you can actually get the same benefit of the Exadata, but by going to the cloud, service options. You do notice that the amount of options that you actually get in terms of the cloud service for the Exadata is not really very different actually. You do get the quarter rack, you do get the half rack, you do get the full rack. The number of codes and the number of storage servers possibly are actually going to be different for you. So you can actually see that the number of storage servers are actually going to be 6 in half rack for the cloud service, 12 for the full rack. And this is basically something which you actually can opt for in case you basically want to go ahead and get the things done on the cloud environments for the Exadata. What you're actually going to be getting is basically going to be a DB node, and you're actually going to be getting access to this particular DB node with the help of the SSH keys. So you'd be able to actually have a DOM compute node available to you. The access of the compute node is basically going to be given to you, and you can actually go ahead and manage it with the SSH keys. You can actually have the backups done. You can actually configure your enterprise manager. You can actually have your databases and all that actually created over there. And this particular system is basically going to be available to you from the Oracle Management Network. The DOM 0, which is actually going to be the underlying interface to manage this entire thing, is not really exposed to you. So you would not actually be able to manage that part. And on this particular compute node, the accessibility will be available to you by a user called OPC Oracle Grid and Root. The OPC user is going to be a user which is actually going to be there for you for this particular compute node access most of the times. And then you can do a sudo and you can actually get to the root that you can actually check out how you can actually access it from your Linux host or from your Windows host. And to do the backups, you do have certain tools like the backup tools or DB cache, and you can actually use Enterprise Manager also for the same thing. So that is basically going to be, of course, you can check the cloud.oracle.com for more details, and of course for the configuration part for this. So that's basically going to be there. Of course, that's really going to be the end of the talk. So the VM images are not really available to you for configuring the box on your laptop. So it's not actually going to be available. Obviously, Exadata and Exadata Cloud Service is actually going to be the future. And of course, it is something which you should really look upon. And these are some of the things which are actually going to be books and docs, which are actually going to be good for the future learning in case you want to go for the Exadata part. I would very strongly recommend the Expert Oracle Exadata book, first edition, second edition for the Exadata, and to know more about the same, and some particular links and some particular meta-link talks for the same. So that completes the webinar for the Exadata and Smart Scan introduction.
Thank you, Aman. That was a session for the users who are new to Exadata. So we have few questions here with us. Wants to know that is it possible to upgrade from Exadata X5 to X6, move from X5 to X6?
Yeah, of course.
All right, and we have another question in a private chat. The person says like he's new to Exadata. What is the environment? Which environment is good to good fit for Exadata?
No, when you say environment fit for Exadata, what does it mean actually?
For that, what you can say that what actually the user is, or she should move to Exadata. What is the time to move to Exadata now?
See, Exadata is one box engineered by one company, right? So in case you're looking forward to have a more streamlined kind of experience, you want to have a more stable experience. You don't really want multiple vendors blaming each other for a lesser performing network. Then of course you can actually go ahead and purchase Exadata box, because the thing is, In Exadata, the network, the storage, the software, everything is provided by Oracle. So Oracle knows how to run the best their operating system, their databases, their applications, with the Exadata box. And in case something doesn't work, they know which part or how they should actually troubleshoot this thing. Now, obviously, if this is going to be, some kind of thing which you really actually want to have, or you think is actually going to be beneficial for you, Exadata is actually going to be an option for you. It is not to say, and of course, the benefits like smart scan, hybrid columnar compression, which are not even available to you outside the box, because the storage which is available for Exadata is not sold separately. So you can't buy the DB nodes or the database server nodes from XYZ vendor, and you can actually buy the storage from Oracle. So it's all actually one box. In order to answer the question that which environment is a good environment, that environment which you think is actually very important for you, the environment where you do need the max performance, and the environment where you actually want to have ease of mind, because you know that you can actually go to one vendor and one vendor only to get your queries resolved, your issues resolved. I would say that is actually going to be the Exadata thing.
Great. The other question we have is, do we have any limitation on the supported operating system for Exadata?
We actually had two options for this. One, we were having the option in these DB nodes. Actually, in the storage server nodes, we never had the option. So we only had something called Linux actually available as the operating system for the storage nodes. But in terms of DB nodes, previously we did have the option to have, or to opt for Solaris, which was actually Intel-based Solaris, or we could actually have a Linux, which is again Intel-based 64-bit Linux. But now, from the latest versions, we do not have this option actually available to us, that we can actually opt for. These two operating systems did actually come pre-installed. So you could actually ask the ACS engineers to, keep whatever operating system you want, and, format the another operating system, mount points actually for you. But now the option is not there. Now the available option as the operating system for the entire box is actually going to be Linux. To you can say compensate for this thing, if you want to call it, there is an option now available to you to configure the Exadata box with your virtualized environment. So you actually do have the option available now to create VMs, virtualized environments on the Exadata boxes. So you can actually have one set of environment on the physical box of the Exadata box, and you can have another, for example, your not standby, I will say, your development or your UAT actually on to be on the virtual environments. But in order to answer the question, the limitation is going to be only Linux on DB nodes and storage nodes. You really don't have the option to use anything else as the operating system for this thing. And it's going to be Intel-based thing.
Okay. And this brings us to the last question, which is, do we have any different ways to migrate data onto Exadata besides the normal export, import, and table space transportation?
Depends actually how big your database is going to be. If you're going to be on a cloud, Exadata cloud service, there are different options. Export import is really not going to be an idle thing in case you're going to be having the very large database. Then Golden Gate, I would say, is going to be a very good option. Arman backups is actually going to be a very good option to migrate, to the Exadata environments. So if you're going to be on a cloud service, then lift and shift is, going to be something which you could actually use. Export import is one of the options, but I would not say that's the only option. Arman, Golden Gate, I would say, are actually going to be, much better options in order to migrate towards Exadata.
All right. Thanks, Aman, for answering all the questions. So this brings us to the end of our today's webinar. I would like to thank you every connected with us. And it's on the behalf of North India chapter, I everyone. We are doing this from last 4 years now. In coming February, we'll be completing our 4 years, and our every webinar and every monthly that our mission is providing you guys an interactive platform. We can share our knowledge with you, and you guys can share our knowledge with us. So if you do want to know about the upcoming webinars, please do subscribe to our YouTube channel, India chapter. And you can also join us on a meetup group. We do have a WhatsApp group. We will be publishing few additional slides at the end of this session and upload it on the YouTube and all the links to our social media. Thank you, everyone. Thanks once again on the behalf of North India chapter.
Thanks, everyone. And as Deepak already mentioned, do actually check our previously loaded videos and webinars for the same. Do give us your comments and suggestions, actually, that what sort of other topics you basically want us to come. We are on Meetup, we are on WhatsApp, most likely on every social media. We are actually there, and we do actually do a monthly meetup, which is actually done every month. So in case you're going to be around in Delhi and NCR region, or in anywhere in North India, we will be actually somewhere hosting a meetup actually nearby to you. And if you
Uh,
do want us actually to come and present somewhere near to you, do let us know. And of course, we want you to actually come and present. So do actually come forward, send us an email. Our email IDs are aiug.nic@gmail and nichapter and n.chapter@aiug.org, which is actually going to be done on the AIUG website. So do let us know that in case you're willing to have any presentations done from your end, and we would definitely help you out.
Aman, before we close, we have another question coming up. So the guy wants to know how many VMs we can use in Exadata. Is there any limitation?
I am not aware of that there is any limitation actually. So, of course, it is going to be depending upon what amount of systems of configuration you basically got. But I'm not really sure that there is any limitation on the number of VMs.
All right. So thanks once again, guys. Thank you.
Thanks everyone. Wish you a very happy 2018 and happy holidays in case you're holidaying. And thanks for joining us on this holiday, and of course on this Saturday morning in India. Thanks, Deepak.
Thanks, everyone.